So now that we've walked through various examples of applying parallel streams, let's take a step back and once again peek under the hood in a bit more detail to see how parallel streams are implemented internally. And a good place to look for more coverage of this is this nice article by Brian Getz, which of course you can find by clicking on the link in the PDF slides once I upload them. As before, it's important to know what you can change and what you can't change. So one question you might ask is, why the heck should we care how the implementation of a parallel stream is done? Why do we care about that? We've already seen that it's pretty straightforward, often, though not always, to convert a sequential stream into a parallel stream just by changing stream to parallel stream. However, as you will see, and as I discovered myself in the last week, knowledge of how streams works internally is guaranteed to make you a better programmer, especially when it comes to performance. And after all, what's the purpose of using parallel programming if it's not to make things run faster, right? We wouldn't go to all this trouble if we didn't get a boost in some ways. So it turns out that there's some really subtle things you need to know about streams in order to be able to get them to parallelize effectively. And sometimes what appears at first glance to look like it's going to work well actually doesn't work well in practice. And we discovered that when we were doing the assignment that I just talked about, the parallel streams crawler assignment. It turned out that our initial implementation, which was very cool and very clever, didn't parallelize properly because of some of the implementation decisions made by the streams developers that are not very well documented, believe me. So that's why it took an extra day or two to get the assignment out, because we were wrestling with these subtleties, and we got it all working, but it's something I want to share with you when we get to the right point. So recall there's these three phases of a Java parallel stream. There's the split phase, where the splitterator is used to partition the data source up into multiple chunks. And then those chunks are handed off as they're created to the common fork join pool, which we'll talk about in more detail, and process those chunks in parallel. And then the chunks are combined together for the different subresults into a single reduced result, or merged result, or combined result, or whatever you want to call it. And it's very important to know which of these phases you can control and which ones you can't. So it turns out that you can control splitting, as we've talked about, with splitterators. You can control combining with things like collectors. But the apply stage really doesn't give you that much control, and you'll see why when we get into that in a bit more detail. So that's just a very quick recap of something we've talked about before, just reminding you about the phases, and then also making the point that some things you can control, some things you can't. And so as with many things in life, you just have to accept the things that you can't change, unless you want to rewrite streams yourself, which you could always do.